Hello, welcome back to our lesson. So today we are going to continue our lesson on limits of accuracy part 2. Previously, what we learned is that we learned on how to calculate lower and upper bound of a simple measurement. In this case, in this lesson, you are going to learn on how to calculate upper and lower bound involving word problems, involving the four operation of multiplication, division, addition, and also subtraction. So let's get started with our lesson, okay? By the end of this lesson, you should be able to calculate the lower and upper bound involving word problems. So these are the steps that you need to remember. The first one, you have to calculate the lower and upper bound of measurement. Second, you have to apply the formula. Third, you have to solve the problems. So what are the formula in this case? So these are the formula, okay? If the question require you to use this kind of formula or this kind of equation, and the question wants you to find the upper bound or lower bound, you have to use this calculation, okay? So if you want to find upper bound of the value, then value or measurement that you need to use will be upper bound for both of the values. It's the same with lower bound. If you want a lower bound value, then the value of B and also value of C will be lower bound. However, it's a bit different with division. So for division, in order for you to calculate upper bound, you have to divide it by lower bound. Okay, so value of upper bound A is equal to upper bound of B divided by lower bound of C. Whereas for lower bound, it's vice versa. So lower bound of value B divided by upper bound of value C. Okay, for the third formula will be addition. Okay, so for addition, it is similar with multiplication. If you want upper bound, then all the way the value you need to use is upper bound. For lower bound, all the value you need to use is lower bound. Okay, however, it's a bit different with subtraction. In order for you to find upper bound of a subtraction, then upper bound of the value B minus with lower bound of value C. Okay, for lower bound is equal to lower bound of value B subtract with upper bound of value C. So another two formula here will be A is equal to value B divided by C minus D. So you can just check the calculation here, okay? So I want you to pause this video and copy down these two tables inside your notebook, okay? This table and also this table. Pause the video now. Okay, welcome back to our lesson. So let's start with example 2 inside your notebook, page 29. The question say a rope is of length 8.3 meter, 2.4 meter is cut and taken away. What is the largest possible length remain and the smallest possible length left? So the first step you need to do is that you have to calculate the absolute value. In this case, the unit of measure will be 0.1. So the absolute value will be 0.05. Once you calculate the absolute value, or absolute error, you have to calculate the upper bound and lower bound for both of these values, okay? Once you have done that, then you go back and see the formula. It says remaining. So remaining means you have to subtract. Very good. So in this case, since this is largest possible length of the remaining, so value of A is equal to value of B subtract with value of C. So in this case, the remaining length is equal to the length of the first line original will be 8.3, the upper bound will be 8.35. Subtract with the lower bound, which is 2.4 minus 0.05, then you get 2.35, and the remaining length will be 6 meter. Okay, so now the smallest possible length left will be, you have to use lower bound of the first value subtract with upper bound of the second value. So you'll get your answer to be 5.8 meter. Okay, so that is example 2. Now let's start with example 3. What I want you to do is that try to read the questions and try to solve the problems individually first. Okay, now pause the video now. Alright, so I believe all of you have done example number 3. So let me explain how you solve this problem. Below is a figure of a rectangle with length 8 cm and width of 6 cm. The first question, find the largest possible length of the rectangle. The second, find the smallest possible width of the rectangle. The third question, find the largest possible area of the rectangle, and then find the smallest perimeter of the rectangle. Okay, next you have to highlight those 4 important information for each of the question. Okay, first you need to know the absolute error. The unit of measure will be 1. Half multiplied with 1 is equal to 0.5. So next, the first question, largest possible length, meaning that 8 plus 0.5 is equal to 8.5 centimeter. Largest possible length also means upper bound. For smallest possible width also mean lower bound of the width will be 6, subtract with 0.5, you get 5.5 centimeter. So next, largest possible area. So largest possible area, you know that if it's area, you have to multiply both number. So upper bound of the length multiply with upper bound of the width. So the upper bound will be 8.5 multiply with upper bound of the width is 6.5. Then you get this value, 55.25 centimeter square. Should be square. Okay. So smallest perimeter, meaning that this lower bound of a perimeter of this rectangle. So perimeter means that you have to add all of the lengths together. Okay, so in this case it says smallest meaning lower bound. So lower bound of the 2 lengths plus with lower bound of the 2 width, and then you'll get your answer, which is 26 centimeter. Okay, does anyone got the answer correct all? If you have any question, do let me know. Okay, so let's proceed with example 4. The dimension of the rectangles are all correct to the nearest centimeter. Find the smallest possible area of the shaded region correct to the nearest centimeter. Okay, so now pause this video and then I want you to do it individually. If you have any question, do ask. Okay, thank you. Once you finish these questions, you have to proceed to activity part 2. Alright class, thank you very much and enjoy your day.